Section 4.1. How to structure a technical explanation. A simple framework you can lean on in any interview. Imagine you're in the middle of a high-stakes technical interview, and the question hits. Something about system design or troubleshooting. One of the biggest secrets here is that most answers don't fail because the person is wrong. They fail because the answer has no structure. People often start in the middle, jump straight to tools, or list technologies like bullets on a slide, leaving the listener completely lost. But good engineers don't just know things, they guide the listener through them. And the easiest way to do that is to use a simple, repeatable framework, the same one every time. Think of it like telling a story, but with 4 clear steps. When someone asks you a technical question, try to answer by starting with the context. What problem are we solving? Then describe the approach. How did we design it? Next, mention the trade-offs. What did we gain and what did it cost? And finally, end with the impact. Why this solution worked. And that's the beauty of it. It's short, logical, and incredibly easy for anyone to follow. Let's break it down a bit more slowly. First, the context is all about what was happening. Before diving into tools or architecture diagrams, explain the situation. For example, you might say something like, "We had a service that was growing fast and the database started becoming a bottleneck during peak hours." It's just one sentence, no drama needed. Now the interviewer understands why a change was required. Moving on to the second step, the approach covers what did we do. Here you explain the decision calmly, step by step. For instance, we separated reads from writes and introduced replicas for read-heavy traffic. The application started sending read queries to replicas, while writes stayed on the primary. You're not reciting commands, you're explaining the thinking behind it. Third, the trade-offs address what did this cost us? This is where you start sounding like a senior engineer. Every real decision has a price. You could say, we gained performance, but also accepted that replicas lag slightly behind the primary. So for anything requiring absolute consistency, we still read from the primary. No solution is perfect, and seniors acknowledge that openly. Fourth, the impact wraps up with, how did it help? And with the outcome like peak latency dropped significantly, and the system handled traffic spikes more predictably. By the end, you've given the listener a full, satisfying story. From the initial problem through your approach, the inevitable trade-offs, and the positive results. And through it all, you sounded thoughtful. As an example, consider a weak answer versus a strong one. A weak answer might be, we used replicas because the database was slow. It's short, but empty. In contrast, a structured answer flows like this. Traffic increased and the database became a bottleneck during peak hours. We introduced read replicas to offload read queries, while writes stayed on the primary. The trade-off is eventual consistency, so sensitive operations still read from the primary. As a result, peak performance improved and spikes became manageable. It's the same technology, but a completely different impression. One sounds like memorized trivia. The other sounds like engineering judgment. The real goal of this framework is something powerful. It shows that you understand the business context, design intentionally, see trade-offs, and measure results. Even if the interviewer disagrees with your solution, they see that your thinking is structured. And that's what teams actually hire. Because technology changes, frameworks come and go, but clear thinking stays. So next time you're prepping for an interview, practice this framework on a real project from your experience. You'll not only answer better, you'll think better. Imagine they ask you, how did you improve performance in one of your systems? Most candidates might say, we added caching, and the conversation dies right there. Instead, tell it through the 4 steps. First, start with the context. What was happening? We had an API that handled product searches. As traffic grew, responses became slow during peak hours, and users started noticing delays. Keep it to just 1 or 2 sentences without any technical jargon overwhelming the story. Now the interviewer knows why the problem existed. Moving on to the second step, describe the approach. What did we do? First, we measured where time was being spent. Most delay came from repeated database queries that returned identical results for popular searches. We introduced a cache layer so that frequent search results were stored temporarily. If the same query arrived again, we served it from cache instead of hitting the database. You're not listing libraries. You're explaining the reasoning. Third, mention the trade-offs. What did it cost us? Here's where you sound senior. Caching meant results could be slightly outdated. To balance accuracy and speed, we set short expiration times and invalidated cache entries when products changed. So we accepted a tiny delay in freshness in exchange for much faster responses. It shows you understand the compromise. Fourth, end with the impact. What changed? Average response time dropped dramatically, and the database load stabilized. Users experienced smoother searches, and incidents related to slow queries basically disappeared. By the end, you've given the listener a full, satisfying story. From the initial problem, through your approach, the inevitable trade-offs, and the positive results. And you come across as calm and thoughtful, without any pretense. As a bonus, here's the same story spoken as if you're in an interview. We had an API for product search that started slowing down as traffic increased. We profiled requests and found that the biggest delay came from repeated database queries returning the same results. We added a caching layer, so popular queries were served directly from memory. The trade-off was slightly stale data, so we used short TTLs and invalidation when products changed. In the end, latency dropped a lot, and the system handled traffic spikes much more predictably. Or if you're discussing a different challenge, say scaling a microservice, our user base doubled overnight, overwhelming the authentication endpoint. We implemented rate limiting and horizontal scaling. The trade-off was added complexity in deployment, but response times stabilized and downtime vanished. Notice how there's no bragging, no list of tools. It just sounds mature and composed. That's exactly the goal of this section. End of 4.1.